So Phoebe's going to tell you what the video is about because she's going to annoy me if I try to do it myself. So today's video is about interquartile range and finding interquartile range and range. These are going to be used for variability, which we're going to discuss in class tomorrow. So the goal of this video, yeah, she's getting bored. The goal of this video is to be able to find the median, the quartiles, and the interquartile range, as well as the range, so that you can create a box and whisker plot. So you have learned measures of central tendency in previous grades, where you're asked to find the mean, the median, or the mode. And the measures of central tendency tell you the middle of the data. It takes a set of data and it gives you different measurements to represent the middle of the data. The mean is the average, the median is the literal middle number, and the mode is the one that appears the most. What we're going to start going into is measures of variation, which basically are measurements that tell you how varied the data is. So that's how widespread, how many different numbers are involved in what you call your data set, which is the number of numbers that you collect. There are two measurements that we're going to use to measure variation. The first is interquartile range, abbreviated IQR, which is what we're going to focus on in this video. And then in the next video, you're going to look at mean absolute deviation, which I abbreviate as MAD. So when you're finding the interquartile range, your goal is to find the median and then find the median of each half. So in order to do this, you're going to put the numbers in order from least to greatest, just like you would if you were finding the median. So I like to cross them out as I find them. So when I put the numbers in order, after I do so, I'm going to make sure that I have the same number of numbers in my newly created list as I had in my original list. So again, I did this kind of outside of creating this video, so I know that I put them in order. I know that I have 11 numbers in my original list and 11 numbers in my new list. So I put the numbers in order, 2, 4, 6, 8, 10, 11. I'm going to identify the least value and the greatest value. And the least and the greatest value are going to be the smallest and largest numbers that'll determine my range, which will come in step 6. They're also going to be the endpoints of what we're going to create in the next slide, which is called a box and whisker plot. I'm going to identify the median. In order to identify the median, I'm going to play the cross-out game where I cross out a number on both sides until I get to a number in the middle. So here I know my median is 4. If there's an even number of numbers, you're going to have to take the mean of the middle two numbers, and we'll do that in a following slide. Then I'm going to identify the first quartile. Well, quartile, the core means quarter. So I'm going to focus just at the bottom half of the numbers, and I'm going to find the median of the bottom half of the numbers. So in order to do that, I'm going to play the cross-out game again and identify the number in the middle. Then I'm going to focus on the upper half. Notice I'm not including the median in my halves. The median stands alone. I've drawn a line through it to kind of eliminate it, so it's not on either half of my data. And in order to find the upper quartile, I'm going to again play the cross-out game. And I'm going to know that my upper quartile is 7. So I know that my first quartile is 2, my third quartile is 7, my median is 4. What this means to me, since I've identified the range, my range is 8 minus 1 because my largest data is 8 and my smallest number is 1. So my range is between 1 and 8, which gives me there's 7 numbers, 7 different numbers that are in my data set. To find my interquartile range, I'm just going to look at my quartiles, and I'm going to say, okay, well, my third quartile is 7, and my first quartile is 2, and therefore my interquartile range is 5. So the range of numbers from the smallest to the largest is about 7. And then between the first quarter of numbers and the third quarter of numbers, there's a range of 5. So there's 5 numbers that come between the first number first quartile and the third quartile. It doesn't mean that every single one of those numbers is represented in my list of numbers, but it does mean that there are potentially 5 numbers that come between the first quartile and the third quartile. So we're going to use these 5 important numbers that we found in the last slide, and we're going to use a graph or a data display called a box and whisker plot to help us see the data visually. So the 5 points that are most important from the steps that we found were the smallest number and the largest number, because those 2 numbers allowed us to find our range. The median, which identified for us the middle of the pack. The lower quartile, otherwise known as the first quartile, which gave us the median of the first half of the data, and the upper quartile, which gave us the median of the second half of the data. I'm going to therefore draw a number line, and my number line is going to have evenly spaced intervals, so I'm not just labeling my number line with the numbers that are in my 5 points. I'm going to label them so that all of those data, all of these pieces of data are actually going to appear on my number line, and I'm going to plot those points. And when I plot those points, I'm going to do so above the number line to make it clear. And I'm going to connect by using a box, the first quartile and the third quartile. And then through the median, I'm going to draw a line. From the lower extreme to the lower quartile, I'm going to make a whisker. From the upper extreme to the upper quartile, I'm going to make a whisker. The importance of this data is that, number one, it shows how spread out our data is. If we had a lower extreme of 1 and an upper extreme of 100, okay, our data would be much more varied. There would be a lot of different numbers between 1 and 100. What we can also tell about this is where the 25% or the quarters of our data lie. We know that a quarter of our data lies between 1 and 2. So this is 25% of our data. If we just looked at the number of numbers that we had, we started with 11. Well, 2 or 3 of those 11, okay, are approximately 25% of our data. And then between the first quartile and the median, between 2 and 4, there's another 25%. And between the median and the upper quartile, there's another 25%. And then between the upper quartile and the upper extreme, there's our final 25%. So we can look at the box and whisker plot, and we can say that 50% of our data falls below a 4. So from 4 and below, that's where 50% of the numbers that we have collected lie. We can say that 75% of our data falls below 7, because we know 7 is the third quartile. Well, if it's a third quartile, then it's 3/4 of our data, or 75%. So by looking at a box and whisker plot, we can make a lot of different conclusions. So if I were to walk through the steps from the slide a couple of slides ago, my first step told me to list the data from least to greatest. Okay, so that means that I would take my data and I would make sure that as I'm listing them, I'm crossing them out so that I don't have to worry about skipping one, missing one, and then I would recount it. So when I recount it, I have 2, 4, 6, 8 numbers, 2, 4, 6, 8 numbers. I'm good. Then it says identify the smallest and the largest. That's going to help us. So 83 is the smallest and 100 is the largest. So that's our lower extreme and our upper extreme. We're going to find the median. Here's the trickier part, because in the last example that we did, the median was 1 number. Well, now we have to say to ourselves, okay, well, the median can't be 1 number because I'm not going to cross out 92 and 94. So I know that if I took 92 and 94 and I found the middle of it, it would be 93. Notice that I am putting a line between them. So I'm not crossing neither 92 nor 94 are eliminated. Now I'm going to find the lower quartile by focusing on the second half of my data. I know my median because I just found it was 93. In order to find the lower quartile, I'm going to play the cross-out game again, and again I get to two middles, so I have to find the middle of that, which is 88. In order to find the middle, I would add 86 and 90, and I would divide by 2, or I could just eyeball it and say I know that 88 is the middle. And I'm going to focus on the upper extreme, and I'm going to do the same thing. Okay, now it's a little bit trickier, because now I have 96 and 99. So I know that the difference, the middle of that would be 97.5. What I can tell from this data is a bit more varied, because the range that I found was between 100 and 83. So between 83 and 100 would give me 17 different numbers. Whereas the first one we did only had 7 different numbers. So that's a much wider range. And our IQR, our interquartile range, again would be much more varied, because now you're taking 97.5 minus 88, which gives us a 9.5. So our IQR here is 9.5, and our range is 17. You can also create a box and whisker plot for this, so take a minute and try that, and the answer will be given to you in about a minute. So here are two different examples of what a box and whisker plot would look like using the data from the last slide. Again, the one thing that has to be consistent is your scale, the way the numbers are from each other. So in the top one, my scale is 2, and the bottom, my scale is 5, and the box and whisker plots look a tiny bit different because of that.